Hey, thanks everyone for joining today. As you're probably aware of what we're doing in OpenMetadata, we're trying to build a JSON schema spec along with the REST APIs to understand, how to capture the metadata, and also build application on top of the OpenMetadata. If you visit any of our sandbox, you can see our UIs and everything else. And in this particular webinar, we are kind of looking at, hey, how do we get, extract the metadata from your data sources? Could be Snowflake, Redshift, Hive, or whatnot, and get that metadata into OpenMetadata. And how do we enable collaboration and user participation on that? So in this session, we're specifically concentrating on ingestion side of the story. So yeah, so Shannon going to kind of walk through different ways of setting up this ingestion and how to productionize these ingestion workflows so that you can get you going.
Okay, thanks, Harsha. Okay. Okay. Focusing on my screen. Is it big enough? All right. Thanks everyone for joining. Okay, so I wanted to take some time here at the beginning to summarize just quickly some of the main themes that we're targeting with OpenMetadata. We'll see some of these reflected as we move through this demo. But essentially, there's four things to keep in mind as you think about OpenMetadata. The first is that OpenMetadata is really focused on a centralized, active metadata, single place for everything having to do with your metadata. This is all based on standardized schemas and APIs that are extensible, but predefined based on many years of experience building these kinds of systems. We're also really focused on enabling individuals in your organization to collaborate seamlessly. There are a number of collaboration features in OpenMetadata currently and planned for future releases to really help you improve your data as an organization. Third, data needs to be trustworthy. So we're focused on building trust with data quality, with observability, and with testing. And we'll take a look at some testing examples in the demo today. And then finally, we are looking at how to improve automation, how to improve productivity using automation, enabling you as an organization to leverage the APIs, standardized schemas, to build your own automations as you need them. And we incorporate the same philosophy within OpenMetadata as we build out integrations and automations. Okay, so what I'd like to do here is talk briefly about the setup that I have for OpenMetadata locally. There are several different ways that you can deploy OpenMetadata. What I'm doing is I have a Docker deployment that I've set up using a Docker Compose file. And I've set this up so that I have 4 different services running. I've got MySQL, which OpenMetadata requires as a backing data store, and Elasticsearch that provides UI functionality. So when I'm in OpenMetadata, okay, and moving through the assets that are here, Elasticsearch is indexing these assets and allowing me to search for them, follow a variety of different discovery methodologies to get there, right? And then I've got my OpenMetadata server running. And what I've done here is I've set it up securely using environment variables that essentially allow me to run an OAuth, an SSO setup. Okay. All right. So with this, I've got 4 Docker containers running, each of which runs a different service for my open metadata deployment locally. And this is a great way to get started with open metadata, to kick the tires on exactly what open metadata provides. You will find documentation on how to launch this type of setup in the open metadata docs. Okay, so one reason why I set up admin here is so that I have access to, that I set up security here is so that I have access to some of the admin settings in my local deployment. So I can take a look at services. I can add new services. If I wanted to, I can add new teams, etc. Okay. So with our open metadata deployment in place, okay, then we can begin to explore the ingestion framework. So open metadata ships with 47 out-of-the-box containers. You can see the list of integrations both in the open metadata documentation as well as at openmetadata.org at the website. There are comprehensive docs for all connectors available in the doc site. And for each of these, there are detailed instructions on how to set up a given connector. Okay. All right. So the integrations that Open Metadata provides are all based on the Open Metadata ingestion framework, and there are a few pieces of that that I want to call out here as a basis for our understanding of how integrations work in Open Metadata. So there are 3 essential pieces to consider. One is the source. So think of source as a component that you configure. And for each Open Metadata connector, the source serves as a translator between the data source in question and the rest of the ingestion framework. So a source component will translate the metadata that's there, the data that it's reading from a data source, into open metadata entities as defined by the metadata standard that open metadata includes. Okay, and then from that point on, the rest of a connector is processing the data in one way or another. All right, so based on those entities. All right, so there's typically a source, a processor of some kind, and then a sink. All right, and in most cases, the sink is directing metadata to our metadata server. So in this case, this config file is set up to take Redshift, a Redshift instance, and pull in metadata, and then direct it to the metadata server that I have running in a Docker container here on my local machine. Okay. Some of our connectors have an additional processor stage that will run that does something with those entities prior to dumping them off at the sink, whatever that sink may be. Again, in most cases, it's the metadata server. Okay, so typically it's source, processor, and sink. And the data communication language between all of those So what we're doing with our connectors here, and the reason why the type of sync here is metadata REST is because this connector is configured to use the OpenMetadata API that the metadata server exports, provides endpoints for, and is using the API to direct metadata that's ingested to the metadata server. Okay, so we roll out new connectors with each release, and the ingestion framework greatly simplifies writing your own connector if you need to do that. We have, as I mentioned, 47 existing connectors, so a significant fraction of the most common data services are already covered. But if you do need to write your own, what you would need to do is write your own source component that would serve as that translation layer. Okay, from there, existing processors, syncs, et cetera, will work as they do for other services. Okay, so in this demo, we're going to look at the different forms of ingestion and different ways of setting up ingestion that OpenMetadata supports. Essentially, from an ingestion standpoint, OpenMetadata supports metadata ingestion to capture schemas, sample data, et cetera. Okay, and in this view, we can see some of the metadata that's been ingested. This is just sample data that is shipped with OpenMetadata. All right, so we can run metadata ingestion workflows using a predefined connector or one that you write for yourself to ingest schemas, sample data, and so on. You can also run OpenMetadata usage workflows for supported connectors to capture information such as how often a given table is used in queries, or the columns on which tables are joined. Usage connectors also capture lineage data, enabling you to see the dependency graph for data assets. OpenMetadata also goes well beyond usage and lineage. Trust is an essential element for a healthy data culture. And as of the 0.9 release, OpenMetadata supports metadata standards for defining data quality tests based on the rich metrics compiled by the OpenMetadata data profiler. Okay, so what we're going to do here is look at each of these different aspects of metadata ingestion in OpenMetadata in turn. First, we'll take a look at metadata ingestion. Then we'll look at usage and lineage ingestion. Okay, and then finally, we'll look at data quality and how to configure tests that will help provide trust in your data. Okay, so let's first take a look at ingesting some metadata from a Redshift instance. All right, there are, in the connector docs, you'll find instructions on how to configure metadata ingestion for a number of different options. If you're just doing a quick POC, typically it's probably sufficient to use the one-time ingestion procedure to pull in metadata from one of your data services. There are also options for integrating a data service with OpenMetadata via the OpenMetadata UI, and using your own Airflow deployment if you so choose. Okay, so let's use the one-time ingestion procedure to ingest metadata from Redshift. This uses the OpenMetadata CLI. The base command for the CLI is metadata. Okay, so here I am set up to use. The OpenMetadata CLI. I have already followed the instructions here in the docs to get my to get the Python modules that I need set up. And I'm just going to begin using those to ingest metadata from Redshift. Okay, so what I'll do here is use the config file that we just took a look at. And effectively, all this connector is going to do is connect to the Redshift instance that I have set up and pull in schemas and sample data. One other thing I should call out here is that for Redshift, we're employing a table and schema filter patterns so that we're only including a subset of the data that's there. That'll make this run just a little bit quicker. Okay, so let's go ahead and run this. What I'm going to do here is take us back to the root page for OpenMetadata. We've got 2 services in here currently. Now, when we kick off the Redshift ingestion, okay, go back here, reload, and now we see that all the tables that were not filtered out based on the filter patterns that I specified have been pulled in for Redshift. I can limit the results view here to just those tables. And then we can poke in and take a look at any of them that we so choose. Okay, so what happened here is that the connector running the config file that we took a look at earlier ran and gave us schemas and sample data for each of the tables that are allowed by the filters, all pulled from this Redshift instance. Okay, now we can also set up data services and ingestions through the OpenMetadata UI, and I'll take a look at that in just a minute. But before I do that, let's go ahead and ingest data from another data service, in this case, Snowflake. So just a quick peek at the Snowflake config file, configured with the connection parameters that I need. Okay, and I have that config file in the same directory as the one for Redshift, so I'm going to go ahead and run that. All right, and we'll kick that off. Okay, now these constraints not implemented errors are because we're not currently supporting constraints on columns. That is something that will be addressed in the next point release, 0.9.2. Okay, connector finished running. Let's go back and take a look. And now we can see that we, in fact, have ingested metadata from Snowflake. Okay. All right, so now I did mention that we can also pull in metadata using the UI. And let me show you how we would go about doing that. I'm not actually going to run an ingestion using the UI, but I will show you how to set it up. So what we can see here is that the two services that we included that we just ingested metadata from, AWS Redshift and Snowflake, are included here under database services. And from the settings menu, we can select services and then select a new service to add, database service, messaging service, dashboard service, or pipeline service. In this case, we're going to use a database service. Okay, I can select from any of these. All right. If we wanted to do what we just did, which is ingest from Snowflake, we would follow this path. Okay. Okay, and then I would go through the process of filling in this form here in order to get me over the line in terms of ingesting data from this service. So I can put in just a few elements here to get me through the experience. What I come up with here is you'll see that I get to a configuration page once I've gone ahead and set up my connection details. And there's a mapping from connection details to what we saw in our config for the source. All right. And what we would see for ingestion details maps onto also a portion of the source, particularly having to do with schema filter patterns, etc. Now, in this case, because what we're doing here is setting up a scheduled ingestion, all right? So this is not a one-time ingestion, but rather a scheduled ingestion. We have the option of selecting the schedule on which ingestion would run. What would happen here is that I would configure scheduled ingestion that would run on my Airflow instance over the course of the period of time specified. If I don't specify an end date, the workflows will run on whatever schedule I configure here. So maybe I want to run once a day, and the time I want to run is at 4 a.m. Every day. I'm going to run ingestions, and I'm going to go ahead and start on today's day. Okay. Then I can move through here, and this will give me the chance to go ahead and kick this off and start doing metadata ingestion on a schedule from Snowflake. Again, there are a wide variety of services that are supported from the UI for database services, messaging services, dashboard services, and pipeline services. Okay. Okay, so now that we've done basic metadata ingestion, let's take a look at usage and lineage. So to get usage and lineage data, we need to use the appropriate usage connector. OpenMetadata provides usage connectors for a number of data services. And again, you can take a look at the documentation for a complete list. A usage connector inspects the database internal logs to extract query data. Queries can be viewed directly in the UI, and query data is used to assess the frequency with which a table is used and columns on which it is frequently joined. It uses queries to determine lineage for views and tables created based on data in other tables. Okay, So configuring a usage connector is very similar to configuring metadata ingestion. So let's take a look at, so we already took a look at the Redshift connector. Let's take a look at the Redshift usage connector. Here I'm doing the same sort of filtering, but I'm adding in a processor that will parse the queries from the query log, the database query log. And again, the idea there is to determine the frequency of use for a given table. Also get some information on joins, all right? And then finally, we'll also be looking at, say, create type queries, especially those for views or tables where we're using data from another table to create that view, and that will give us lineage data. Okay. So what I can do, again, using a one-time ingestion approach is I can kick this off. Okay, using my usage connector. Now, this is going to take a while to run because of the processing that it does. All right, and so what I'd like to do instead of wait for that and then dive in is just go ahead and dip into the sandbox to get some examples for the kind of data, the OpenMetadata sandbox, to get some examples for the type of data that you can pull using a usage connector. Okay, so one example is queries. So we get from a given table, okay, we get a quick view of all the queries that the usage connector was able to pull in for that particular table. We also get some useful information in the form of a usage percentile, okay, and some other details about this table, including frequently joined tables. Okay, so all of this information is available to you in the OpenMetadata UI. And the idea is, again, going back to the four main themes for OpenMetadata, the idea is to provide you with, you and your users, other members of your organization, with an effective means of assessing the quality, the utility of any data asset that you're looking at. In this case, this is a pretty heavily used table. It gives us some confidence that the data that's here is usable, and even hints at a decent amount of quality for that data. The frequently joined tables option, widget in the UI provides us with a means of discovering related data for this asset, which we might have brought up in search results, and giving us therefore another discovery mechanism that we can use. So the usage connector is really designed to provide a number of details that help you make choices about whether or not to use a given data asset, but also to use a given asset as a means of discovering more data assets that might be of use to you. This connector is also pulling in lineage data, and we can take a look at another table from the same database, from the Shopify database, to get a view for the type of lineage information that the connector is pulling in. In this case, this being the raw customer table, we can see that it is a source for a number of assets throughout our data sets, our data ecosystem. There is an ETL pipeline. It is used to produce the table of public orders. Another ETL pipeline. Each of these pipelines are used to produce additional tables and so on. Okay. All right, so now let's turn, so now we've looked at metadata ingestion, all right, to get schemas and sample data. We've also looked at usage ingestion to aggregate statistics on the use of assets and lineage. Now let's turn to the third main concept around data that we want to focus on today, and that is data quality. So this is really an area in which open metadata is beginning to distinguish itself in a few different ways, which we'll dive into here. As I mentioned earlier, as of the O.9 release, Open Metadata supports metadata standards for defining data quality tests based on the rich metrics compiled by Open Metadata's data profiler. All the test results are stored in a time series fashion and can be retrieved using the Open Metadata API. The UI currently shows the last execution and will continue to iterate on the user experience to make testing approachable and more integral to the data lifecycle. So with our data quality experience, you can discover and understand data as well as determine if a particular data asset is reliable in this centralized open metadata store. So again, the first main theme of open metadata being a centralized metadata store, a single place where you're going to get your metadata and everything having to do with understanding data in your organization. Adding quality to that allows you to marry that quality experience with discovery to really assess the data assets that you're looking at. So let's go back to our here we go. And we'll look at Redshift. All right. And I want to take a look at one table in here, orders. All right, and we'll take a look at the profiler tab. Okay, so currently, because we haven't run a profiler ingestion yet, the profiler tab is empty. When we run the profiler, it's going to calculate values for a number of metrics that we can use to help assess the quality of data. We'll go a step further then and create some data quality tests for this table. Okay, so here's our profiler config. All right, and using the same source effectively. But then we've added the processor stage that is going to run the profiler. And optionally for the profiler, I can actually specify some tests to run in the profiler. Okay, so let's go ahead and do that here. Let me just do a quick mapping onto raw orders. Okay, got this user ID column here. And that is actually the column on which I'm going to create this test. Very simple test, just ensuring that the user ID falls in a particular range. In addition to creating this test, the profiler is going to produce metrics across my Redshift metadata, the assets, the tables that I'm pulling in from Redshift based on my filters. Those will also help us assess any assets coming from this instance. Okay, so let's go ahead and run the profiler. Okay, so in this case, again, using the OpenMetadata CLI, again, based on the metadata command, only instead, this time I'm going to run the profile subcommand and run it on that config file that we just took a look at. Okay, good status. A couple things to point out. We can see the test reflected here in the output. The workflow finished successfully. That means the test passed. Now let's go take a look at the OpenMetadata UI and look at the profiler tab. Okay. And what we'll see is that now across all of the tables that I have included here, we now have profiler information. Okay, profiler gives us information on distinct values. It depends depending on the data type. If it's a numeric type, we get a min, a max. We can see the mean value, and there's some additional descriptive statistics that are provided. Okay, if it's a more of a string data type, we'll get some different stats. But the idea here is that these metrics give you additional information about any data asset you're looking at to help you understand what is being provided with that asset and any potential problems that you might see. Okay. If we take a look at the data quality tab, let's go back to raw orders. Actually, before I do that, if we take a look at raw orders, again, raw orders is where the table on which we were running this test. We can see from the schema view a column there in this presentation of the schema that is there for data quality. And we can see that there was one test that ran and that test passed, hence the green check mark. We can get a little bit more detail if we go into the data quality tab, all right, get a little bit more detail about that particular test, exactly what it was, how it was set up, what the details are for it. And what the result was for running that test. Okay, once tests are configured, they will run on the same schedule as the workflow that you established. In this case, we set up a one-time, so these are going to run once. But if we were to do this as a workflow that's deployed on Airflow or another scheduler, they would run on a schedule. Okay. All right, so we can also set up tests in the UI. So let's go ahead and take a look at an example of doing that. I'm going to go to the orders table for this and go into data quality. Let's go ahead and add a table level test. We can set up a couple of different types of tests. They can be either at the table level or at the column level. I'm just going to do a quick test at the table level, and I'm just going to use table column count as a simple example of this. You do have a couple of other options. In this case, This test will ensure that the test is happening, that the table has 9 columns, that its schema isn't being modified effectively in terms of the number of columns. Okay, and then I can choose the frequency with which this test will run, and we can add that test. Okay. So that adds a single test because this is a different table from the one we were looking at. Now let's add a column test. Okay, so we're going to add a test now on, let's add one on coupon amount. All right. And I want column values to be between. All right, and let's say we want a business rule that coupons should never be more than 25%. Right, we'll go ahead and set that test up to run daily. Okay, and then excuse me. Okay, so then let's set up one more test. We'll do a column test. Actually, let's take a look at the profiler values. I want to set up a test that will that's going to pass. Okay, and let's look at status here. Take a look at some sample data. Okay, go back to my schema. All right. Yeah, let's add one on gift card amount. So go back to data quality, add a test. Oop. All right, and let's say we don't permit gift cards any more than $100. Okay. Okay. Taking a look at the profiler. Okay. Based on what's here, that test should pass. Okay. All right. Let's go ahead now and run our ingestion again. Or sorry, our profiling task again. Okay. This workflow finished with some failures. Okay. And if we take a look at the data quality tab, we can see that as expected, the coupon amount test failed. And this is because the actual max coupon amount that we find in this data set is 26% versus our expected max of 25. Okay, so up to this point, we have run, we have taken a look at how to do metadata ingestion on a few different services. We looked at doing this both from the metadata CLI as well as from the UI. And we've talked about usage ingestion, which gives us usage data and lineage information on data assets. And then finally, we just took a look at using data quality and how that can help inform the kinds of choices that we might make about data in our as we're choosing data assets to use for one project or another. And all of this provides a decent sense for how we might go about putting together a POC, proof of concept of open metadata for our own organization. You can see how you can integrate existing data services that you have with open metadata. What we haven't quite talked about yet is how you might go about productionizing this. So if you already have, for example, an Airflow deployment and want to use that Airflow deployment as your workflow scheduler, and it might well be the case that the way you'd like to do your integration or to productionize your environment would be to use that scheduler directly to add integrations for open metadata to consume and use as part of what it provides as an environment for this one-stop shop or single source for assessing data, finding data, assessing quality, et cetera. So for this aspect of things, I want to turn the demo over to Per, who's been working on a lot of this type of functionality within open metadata, and give him an opportunity to demo that aspect of metadata ingestion in open metadata. Per, are you ready to go?
Sure, let's do that. Let me steal your screen, please.
Yeah, go ahead.
Perfect. So, well, thanks again, everyone, for joining. And what we're going to see now is a bit the goodies that we get from configuring the ingestions and the workflows on Airflow and how we can actually get that running. So the important thing here to notice is that when we're talking about this metadata ingestion and profilers and so on, that comes bundled as a Python package, right? So if we are thinking about how we can make available these processes and these workflows in an Airflow installation, the only thing that we actually need to handle here is actually the installation of our workflows into the instance that we want to use for running all of these ingestions. So on the one hand, you could use the Docker image that we have already customized with all of these packages, or otherwise you would just need to install the Open Metadata Ingestion package with a couple of plugins. The first one would be this Airflow container, which aligns a bit the versions that we need for the profiler and so on with the requirement constraints on Airflow side. And in my case, I was just testing it out locally using a standalone Airflow deployment, and I wanted just to play around with MS SQL. So I'm just passing here the MS SQL plugin as well, so that whenever we get to run the Airflow DAG, it knows how to pick up all the packages required to understand and connect to the sources. So that being said, just a sample DAG on how to ingest data from MS SQL and run it in Airflow could look like this. So the actual structure is exactly the same that we are doing, for example, when we're running the CLI application. The only thing that we need to manage here is to actually pick up the classes from the Open Metadata workflow and put them inside of our DAG, right? So in this case, I'm importing our metadata ingestion workflow class. And from this class, I'm creating a specific function. And this function is going to know how to handle the loading of the configuration. And then it will just create the workflow, execute it, and making sure that if we are having any issues ingesting the data, the actual DAG also fails, right? Because this is important. We just do not want any false positives going around. And with this function already set up, here we are just working with a simpler Python operator. We are also planning to evolve a bit the Airflow integration, playing with also Docker operators and so on, which will make it a bit easier to handle all of the different requirements in multiple hosts. But right now, the Python operator is good to go for most of the cases. And we're using this Python operator, just defining a single DAG with a single task that will be named ingest MSSQL, and I'm just passing this specific function here. Then this function just loads this configuration, in this case, this string, which is exactly the same that Shannon was showing to you before, right? So I'm just taking this JSON configuration, wrapping it up in a string, and configuring for it to actually run in a local MSSQL that I have running in a Docker, right? So I'm just pointing to my local host, putting my username and password, and filtering some of the tables. And with that, if I go to my local Airflow instance, we will see how I get this MSSQL ingestion. Notice how so I did not say that, but this actual file, I have it created inside my tags folder, okay? Because I have this Airflow instance running locally. If you have a remote server running Airflow, you will need also to make sure that you are deploying all of these tag definitions inside the required folder on that server. And taking a look at this task, right, it just runs exactly the same that Shannon was showing, because in the end, we are executing the same package. And just by running that, we will be able to see the same information here. So I filtered the users and the users view table, and I get all of this information here already in my OpenMetadata UI. The same way that we can configure just metadata ingestion workflows, it's symmetric for working with the profiler workflows. The only difference is that I will need to use the profiler workflow class instead of the ingestion workflow class, and specify here my processor. Again, the same way on how you would do that for the CLI usage. And by running this on my standalone Airflow, all of my profiler metadata gets also run here. What's also interesting to notice from the Airflow side is that if we get this configuration done on our host, we can not only run these workflows, but we can also automatically ingest pipeline data and task data and keep picking up all the task status of what we are running in our Airflow, right? For that, as well in the OpenMetadata ingestion package, we can configure this lineage bucket. So in this case, I'm configuring this OpenMetadata lineage backend that is pointing to my OpenMetadata server. And if I were to run, in this case, I have just another sample DAG called lineage tutorial. Just by running this, this one here, right? So I will be able then to find the same information of this pipeline and these tasks directly in OpenMetadata. So if I go to my pipeline service, I can find this lineage tutorial with all of these tasks. Not only with these tasks, but if we jump now into the lineage view, I'm able to directly into the DAG code provide lineage information. In this case, I'm saying, okay, I have this task T1 and this task T2. One of these tasks is outputting, is having as an outlet a specific table, in this case, the DIM address from BigQuery, and this other task is having as an inlet table as a requirement for it to run this DIM customer. So this lineage backend is able to actually parse all of this information and also send it automatically to OpenMetadata. And just to close, because we are near to the end, I was just seeing in the chat that some of you were interested in also being able to track the status of the Airflow tag and the status of the tasks. This is something that we're currently working on. It's already supported in the API, right? So this is already happening in the backend. And if I just pick up this lineage tutorial pipeline and I request the fields of the pipeline status, I'm able to see here that the actual execution failed because I had this explode task here that was failing, but the rest of them were successful. So this is something that the same status here will be continuously captured just by running it with the Airflow backend configured. And we will keep working also making all of this information available directly in the OpenMetadata UI. And that's it from my side. Sorry, it took a bit longer. Back to you, Shannon. Thank you very much.
Thanks, Per. Very, very useful, very informative. Okay, folks, we are at time and we managed to squeeze it all in. That wraps up our demo and walkthrough of metadata ingestion, the ingestion framework, usage and lineage ingestion, and data quality for this webinar. Thanks everyone for attending. Harsha, is there anything you'd like to say in closing?
Suresh, okay. Yeah, thanks a lot. I hope this makes it clear on how easy it is to set up an ingestion workflow and get your data into the open metadata and enable the data collaboration, data discovery, and all the use cases that we support today. And we continue on this journey to improve and improve the open metadata in the coming releases as well. So please join our Slack, and we are very active on Slack. We would love to support you and answer any questions you may have, and also kind of understand what your use cases is, and if there is anything that we don't support today, we'll definitely make that as a part of our roadmap. So thanks again for taking this time, and yeah, let's wrap that up.
Okay, thanks everyone.
Thank you.
Thanks very much.